Hello guys and dolls, welcome back. We are at Formnext 2025. This is our 4th year here at the largest 3D printing and additive manufacturing show in Europe. We've got lots of exciting stuff coming up. Stay tuned. See you in the next video. So, a quick pause from the video to say a thank you to the sponsor of this video and of the channel, Frozen, and talk about the printer that we've been playing with a lot recently, the Frozen Mega 8KS. The best way I can describe this thing is it just makes big resin projects feel normal. You know when you see a huge model on Etsy or a full-size army and you think, oh, that'd be really good. I definitely can't do that on my machine. That is all fixed by the sheer size and volume you can print with this machine. The build plate is huge, so we've been doing full trays of minis all in one go, big terrain pieces, chunky props, and it has handled it without any drama. You set it up, you slice it, you hit print, and it just gets on with it. It's really nice not having to chop everything into tiny sections, make inorganic cuts, just to try and make it fit. And even though it's a big machine, you still retain all of that crisp 8K detail that you want from resin. This thing does textures on cloaks, little rivets, tiny text, and it all shows up nice and clean, nice and crisp. On the table, in a camera, it just looks sharp. There are some good quality of life bits on this as well. The lid design makes it nice and easy to fit it in normal spaces. The whole printer feels like it's built for people who are actually using it every day and not just for a spec sheet and a bunch of flashy marketing things. If you're thinking about stepping up to a larger resin printer, whether it's for batch commissioning, full print in armies, or just finally doing one giant centerpiece model that you've been putting off, you have to look at the Mega 8KS. Use the link in the video description, and a big thanks to Frozen for supporting the channel. Now let's get back to the video. Hello guys and dolls, welcome back. We are at UpNano. Talk to me a little bit about what you guys have brought to the show and what it is you do.
Thank you very much. Well, this is the 3D print show, and we are the experts for high resolution printing. That means we can print extremely small stuff. And if I say extremely small, I really mean extremely small. The things that we print, you can often not see with the naked eye. We can print down to structural elements and tolerances of 100 nanometer and below. And this is about 1,000 times thinner than a human hair. This is really difficult to imagine. And that's why we have done an example here to kind of visualize that. This is a nice one because it's fluorescent, and we can print over 4 centimeters high structures with very fine and filigree details, but we can print that smaller, smaller, and even smaller. The smallest dot is about 200 micrometer high, but if you put this into a scanning electron microscope, you see the same structural details like with the big one. And that's the uniqueness of this technology. We can really print stuff that cannot be produced by any other means.
So when we normally talk about resin printing, we talk about MSLA, or we talk about sort of getting down to about 100 microns kind of thing. That's not what we're talking about.
No, it's 1,000 times more
precise.
It's
1,000 times more than what you could do on a regular machine. Yeah. So talk to me a little bit about how the technology itself actually works without giving away a number of very legal trade secrets, obviously.
No, that's fairly transparent, and in principle it's a lithography procedure. So we slice our object in slices, and then we print dot by dot. We call these dot volume pixels or voxels, and we use a technology that's called two-photon polymerisation. And two-photon polymerization is a non-linear process, a physical principle that allows us to get to this extremely high resolution. The smallest voxels that we can print are in the range of 100 times 300 nanometers. Then we can position them extremely precisely and even get surface roughnesses down to 1 nanometer surface roughness. So in principle, it's a lithography procedure using two-photon polymerization, and that's how we achieve this phenomenal resolution.
So that's, I mean, we're not just talking best in class in that instance, we're talking about something that is ultimately pretty revolutionary, and then you've got this contained in a pretty domestic-sized machine. I mean, it's a tabletop printer, right? I would have expected this to be in. You have an industrial machine, the Nano Pro, which is obviously for much larger for sort of much larger pieces. But this, what sort of sectors are trying to target things that are this size that would use this?
Well, first of all, that is a masterpiece of our engineers, and it's thousands of hours of engineering to compress everything to this small size. This is a clean room. There's a HEPA filter inside, and we have a clean room condition because dust sometimes is bigger than what we print. So we have to run it as a clean room. This is laser safe. The laser is inside. Sometimes other companies come and look below the machine because they think everything is below the machine. Everything is contained in this system because we know that especially in the academic field, space is limited and people don't have huge areas for new machinery. And this was meant to be a desktop machine, highly flexible, high competence, high speed, high precision. The vibration isolation is built into the machine. You don't need an optical cable, so this is really a phenomenal machine that can cover everything. And the idea that we follow as a company is that we make this process fast. This process did exist since several years, but it was considered a very, very slow prototyping process. We think the opposite. We think this is the fastest of all print technologies. And with this machine, we already set a new standard. When we hit the market, we were about 100 times faster than the state of the technology. And we want to speed it up further because why would you produce a new structure here when you cannot scale it up in the industry and then multiply that? The second generation of the machine will be the Nano Pro. The Nano Pro is printing the same precision, but the machine is bigger because it's more robust, it's even more robust, even more temperature controlled than this one, and it has a much bigger travel range, and it can produce much higher quantities of products. You raised the question what it is made for. We have a lot of customers in the academic field, researchers, top researchers from material research, microelectronics, microsensoric, physics, many other areas. And in the industry, we have a lot of customers from medtech. Medtech, everything gets smaller and smaller, be it microendoscope tips or be it microfilters, microfluidic chips for cell treatment. This is a big area, but we also have a lot of customers from micro-optics and microelectronics. We can print extremely small lenses with extremely smooth surface precision in any form, lens form. Spherical lenses, aspheric lenses, free-form lenses, staggered lenses in transparent materials. And if you want to put a lens on a tip of a 100 micron fiber, you need it's a tenth of a millimeter, you need to hit the center of this fiber and print a precise fiber. We can put that into a fiber holder, we can perfectly match the center of this fiber and print this highly precise lens. And that's a big industrial application when it comes to optical switches, when it comes to micro-optics, lens arrays, all these things. So there are different industrial areas that have a need for this technology, and we're just at the beginning to introduce this technology to the industry.
So obviously, I mean, you said the technology's been around for a while, but the reality is it's either been unobtainable to a large number of people or it simply wasn't scalable because for cost reasons and speed reasons. So what kind of support are you giving clients when it comes to workflow arrangements and actually building an ecosystem and a workflow that sits around this? Because if it's something that previously they didn't know how to do because they didn't have the tools, they've now got the tools, but they still don't necessarily know how to actually implement that into an end-to-end workflow. So are you supporting them in that piece as well?
Definitely. First of all, before a customer wants, the main business is selling this machine still. That might change in the future, but right now it's selling this machine. But before anybody invests in such a piece of equipment, people want to know whether this solves their problem. So we offer feasibility studies. 1 or 2 days is free of charge. If there is a longer feasibility study, well, then we have to agree on some payments from the customers. But we want to allow the customer to really work hands-on with this machine, experience with it, get support from our team, and then take a decision whether this is a solution to their problem. And if you don't need the precision, there are many other machines that you can use. If you need the precision, this is a wonderful solution. So of course we try to help the customers. Once the customer is in our camp, we support the customer with everything that we can. Every year we have a customer scientific 2-day customer expert meeting that we host, and we invite from customers from all over the world, and many of them come. Over 50% of the customers we have in this scientific event. We would give lectures, customers would give lectures, and we try to learn from each other and push the boundaries of this technology further out. There is a second company, a sister company, that offers pure print service. So if you don't want to buy a printer, you just have parts to. We have a sister company, and we work closely together, and they would run the printing for these customers. And for the industrial manufacturing, we will build up a clean room facility, or we're in the process of building up a clean room facility with several of these machines, with robotic handling of the substrates, and we could then exclusively produce microparts for selected customers.
Printing as a service is really interesting because there's a reality that there is a cost to market to be able to get one of these machines in. And when we're talking about universities, they may have very specific niche, time-sensitive requirements that may not require them to actually own the machine for long term. So that's really interesting. Again, I mean, it's incredible what you're able to actually achieve with the level of sort of clarity and precision that you are. But thanks very much for taking the time. We'll catch you on the next video.
It was my pleasure. Thank you very much. And the big one is over 4 centimeters, and I think none of our few competitors can do 4 centimeters. You can put a pencil here.
Yeah.
And this is the tip of the pencil. We had an art project. This is the smallest one, yeah. We had an art project that we called Castle on a Pencil Tip. That's why we have pencils. And we printed, like this, in the size of this Eiffel Tower, we printed the castle on the tip of the pencil. And if you put it into the electron microscope, you see a mountain, a rock-like structure. This is the pencil tip.
I've seen that.
The castle, yeah.
I've seen
that's
that.
a wiki science project. And that was an idea of our engineers to explain people from the street the dimension below 1 micrometer, 1 micrometer and below 1 micrometer.
Brilliant. Perfect.
The Nano One high-resolution 3D printing platform offers a flexible print range for structures above 40 millimeters to below 100 nanometers, utilizing patented technology that allows for unmatched throughput and tolerances. The Nano One offers a vat-based photopolymerisation approach. This, paired with a large material reservoir, enables the use of a wide range of resins, allowing for batch production of complex microparts. Our powerful operating software, Think3D, offers adaptive resolution, including fine, coarse, and outline modes, to adjust precision and speed where needed to better optimize print times. The vat printing process builds parts layer by layer in block sections, allowing for nearly limitless design freedom with up to 450 cubic millimeters per hour throughput. Nano One printing systems come in a ready-to-use standard configuration, but are also customizable with additional accessories to suit user requirements. These upgrades can be easily retrofitted at any time, so the printing system can evolve with changing demands. Whether producing nanostructures, manufacturing medical devices, printing directly on functional chips, or creating precise masters for replication, Nano One is the trusted solution. UpNano, upscaling nano fabrication.
2018, our journey started with the launch of Nano One. But this journey wasn't intended to stop with just one product. It was the start of something much bigger. In today's fast-paced, high-tech world, it's often the smallest components that drive innovation forward. To support the development and enhancement of cutting-edge technologies, there's a need for a service capable of producing high-quality microparts in mass quantities. At UpNano, we've risen to this challenge with NanoPro, our advanced industrial micropart production service. We can produce centimeter-sized parts with extremely complex structures and micro details, as well as microparts that are invisible to the human eye. NanoPro unlocks new opportunities for mass production, delivering industrial microparts at a speed, quality, and volume that is unmatched in the current market. We also provide expert assistance in optimizing your microparts. With our skilled technical team and state-of-the-art equipment, we guide you through every step of the manufacturing process. From the initial briefing about your unique product requirements, to producing test batches with our prototyping machine, the Nano 1, to evaluation, iterations, and finally, the last step, serial production of your part. Whether you need to produce thousands or millions of parts, our industry-leading solution ensures a maximum of quality and efficiency. NanoPro by UpNano.